This is 8.5, part 2, and in part 2 we're going to discuss multiplicity. So multiplicity is how many times a particular number is a zero for a given polynomial. Specifically, we're going to talk about something that has multiplicity of 2. So if a 0 occurs twice, it has multiplicity of 2, and you'll hear me call it a double root. So it's a double root because its 0 occurs twice. So an example of something that would be a double root or have a multiplicity of 2 is this function here, f of x equals x plus 2 squared times x minus 4. Because if we were to rewrite this, we should see and know that x plus 2 squared is just x plus 2 times x plus 2. So it happens twice rather than just once, like x minus 4 would have a multiplicity of 1. It only occurs once. So what are the zeros of this function? Well, the zeros of this function are x equals negative 2 and x equals 4. However, we only see that we can only write it twice. However, x equals negative 2 is a double root or has a multiplicity of 2 because that 0 happens twice within our function. So how does that affect our graph? Well, what happens to the graph at x equals negative 2 is it's going to bounce off of that 0 rather than crossing the x-axis. So what that would look like is if we had an axis and we had a 0 at 4 and a 0 at negative 2, we also know here that our y-intercept should be at 2 times 2 times negative 4. So it would be at negative 16. So when this is rewritten, we can see that it actually has 3 x's. So it is x to the 3rd power. It's a cubic or of degree 3. So its general shape should be like this because it is positive. So what's going to happen at this 0 here, this is where our double root is going to be. When we come up to that root, instead of going through, we're going to bounce off and we'll stay below the x-axis in this instance instead of crossing over that x-axis. So this right here is our double root. We can see that it bounces off the x-axis when we have a multiplicity of 2. Now let's look at an example of graphing a polynomial with multiplicity of 2. So given the factored polynomial f of x equals x times x plus 2 squared times x plus 3, we want to know how many real zeros does it have. Well, right now it looks like we only have 3, but we have this multiplicity of 2, so that means this x here occurs twice. So we actually have 1, 2, 3, 4. It actually has 4. And if it helps you to rewrite this, go ahead and rewrite it to x plus 2 times x plus 2 times x plus 3. Now we can more clearly see that there are 4 zeros here. So what are these zeros? Well, we have x equals 0. We have x equals negative 2 and x equals negative 2, as well as x equals negative 3. So x equals negative 2 occurs twice, so we see that this is going to be a double root. It's going to bounce off of negative 2. So what degree is this polynomial? We have 1, 2, 3, 4 zeros, so it is of degree 4. Just because it's a double root doesn't mean it just counts as 1. It's a double root, so it's 2 zeros, so it counts as 2. So is there a double root? Well, yeah, we just discussed that we have a double root at x equals -2. So we want to now go ahead and sketch it. Well, if we know that this polynomial is of degree 4, we know that it's that W shape. It's also positive because we can see that there's no negative out in front here. So it's going to be positive, so it's going to be ending up. Since it's degree 4, it's even, it's going to end in the same direction. So we know our graph should look something of this shape. So if we go ahead and draw, we want to put in our intercepts. So if we put in our x-intercepts, we have an x-intercept at 0. We have one at -3 and -2. When we sketch, we want to put all our intercepts. So we need our x and y-intercept. So, well, what would our y-intercept be in this case? To find our y-intercept, remember, we have to plug in 0 for x. So if we have f of 0, we have 0 times 0 plus 2 squared times 0 plus 3. So we have 0 times 2 times 3, which ultimately is 0. So our y-intercept's also at 0. So we don't have to add an additional point on there. So we need to be careful because we have to make sure we account for our double root, and our double root's going to be here at -2. So as we draw this, we know that we start positive, we come down through our point, we come up, we have a double root, so we bounce off and then finish our graph in the positive direction. So our graph should look something similar to this. Now, how much you go down on both of these minimums here is going to be slightly different. So this is a possible graph of this polynomial. The last thing we're going to look at is being able to sketch a graph given a polynomial that we have to factor first. So go ahead and copy these down. I'd like you to factor both of these. Once it's in factored form, see if you can sketch a graph of both. So we can see that the first function factors out to x times x plus 3 times x minus 2, where the second one factors to x plus 1, x minus 1, x plus 5. So both of these are cubics. They both have 3 real zeros. So in this first one, we see that we have x equals 0. We have x equals -3. And we have x equals 2. So if I were to go ahead and plot these, I have 0, I have -3, and I have 2. Since it's positive, I know my general shape is going to be an N. It's going to finish up, start down. And what's my y-intercept going to be? Well, if I plug in 0, I have 0 times 3 times -2, so it's going to end up having a y-intercept at 0. So if I sketch, I start down, I come up, go down, and finish up. So I have this cubic here. If I look at my example on the right, I have a 0 at x equals -1, a 0 at x equals 1, and a 0 at x equals -5. So I can go ahead and plot these on my x-axis. I have -1, 1, and -5. This is a cubic positive, so I know it's going to be of this general shape, start down, end up. And, well, what's my y-intercept going to be? Well, if I plug in 0, I have 0 plus 1 is 1. 0 minus 1 is -1. And 0 plus 5 is 5. So I have 1 times -1, which is -1, times 5, which is -5. So I'd be at 0, -5 as my y-intercept. So if I sketch my general shape, I start down, I go up, I come down through -1, make sure I hit my y-intercept, and come back up. I have my general shape of a cubic with my x and y intercepts.